This lesson is on slope-intercept form. So if you're in front of a computer, I would encourage you to go to this website right here and graph each of these equations, and then graph other equations and see if you notice a pattern that keeps occurring. So for example, if we go to this website and we would type in y equals 3x plus 2, we would get a graph that looks like this. So what I'd like for you to do is just draw a sketch of what it looks like right here on the graph for yourself. Okay, then go ahead and graph y equals negative 3x plus 2. So what I want you to see here is that I kept this plus 2 number here the same on both. So here's y equals 3x plus 2. And what I want you to see here is that this number right here, the constant was plus 2. And it crossed the graph on the y-axis, or the vertical axis, at positive 2. Then when we had y equals negative 3x plus 2, that plus 2 constant number is where the graph crosses the y-axis, or the vertical intercept. So both of your sketches here, the graph goes through positive 2. Okay, then notice I kept the numbers both 3 here, but one is positive and one is negative. So here it's positive, and if you remember from the last couple lessons, we talked about slope and we talked about rate of change, and that number there is positive, and from the left to the right, the graph is going upwards here. Whereas this one, it was negative, and the graph is going downwards. So because this is positive 3, it's going to go upwards, and because it's negative 3x, this one's going to go downwards from the left to the right. So that 3 there seems to represent the slope or the rate of change number. So as we talked about in past lessons, if we pick 2 points that we could read nicely, like those two, and we do rise over run, I'm going to start at the bottom point, and I'm going to rise 1, 2, 3 boxes, and then run 1. So 3 divided by 1 is 3, and it's positive because it's going up. So that's what that number, when it's in y equals mx plus b, stands for. This is the slope, and this is where the line crosses the y-axis. Okay, so now we're going to go ahead and graph y equals 1/2 x plus 3. So we're going to put this in the graphing calculator, but for right now we should suspect that it's going to cross here at 3, and because this number here is positive, it should go up. So this is positive 3 right here, so it should cross at 3, and because this number is positive 4, it should go up. So let's go ahead and see what it looks like on the graphing tool. Okay, so we put in, as you could see, it crosses at 3, and if I pick 2 points, rise over run, we're going rise 1 and run 2. And then if we pick the next point, it's rise 1 and then over 2. Rise 1 and over 2. So that is the rate of change. That is the slope number in front of the x. Okay, here we have y equals 4x plus 3. So again, you could see it crosses at 3. So if I pick 2 points like these two here, since the slope number here is 4, my rise over run, 4 divided by 1 is 4. So I'm going to rise 1, 2, 3, 4, and go over 1. Rise 4, 1, 2, 3, 4, go over 1. So rise 4, go over 1. The whole way through. So after a little discovery here, we see what the job role of each of the numbers when the equation is written in y equals mx plus b. So let's go ahead and write some stuff down. Okay, so we call this form slope-intercept form, and that is when the equation is written as y equals mx plus b. And when it is, the slope is the m, so whatever number is in front of the x is the slope. So the number in front of the x, and it represents the rate of change or rise over run. Okay, whereas this number over here, b, it is the y-intercept, or the vertical intercept if we're not using y. And if there is not one, so for example, y equals 2x, so it doesn't have a number here being added or subtracted, then it's like 0. You can add 0 to anything and it doesn't affect it. So if there's not a b value, it's 0. So it crosses at the origin. So the next few examples, it says identify the slope and the y-intercept. Circle whether the line goes upward or downward, horizontal or vertical. So if we look at the first equation without even graphing it, we know that y equals mx plus b when the equation is written such that the y is by itself, that the slope is the number in front of x, and the b is where it crosses the y axis, so the y-intercept or the vertical intercept. So our m is 3, our slope is 3, and because the slope is 3 and it's positive, we know the graph, when we graph it, will go up. And then this number here, the -2, tells us it will cross the y-axis at -2. So here we go, here's the graph. I graphed it with the graphing tool, and you could see it crosses at -2, and it's going upward, as we indicated here. Okay, over here, the number in front of the x is the slope, so -5. And then this number here that's being added or subtracted, there is not one, so it's like 0. So the b value is 0. That means it crosses at the origin. And since this slope number here is negative, the graph would go down. So it's downward. And I asked the graphing utility to graph it, and as you could see, it crosses at the origin, and the graph is going up because it's +5. The equation we were given was -5. I messed that up there, but you could see that it's supposed to be going down, whereas this one is +5, that's why it's going up. But you could see that it crosses still at 0 there. All right, let's take a look at example 3. It says y equals 2. Well, first of all, you should notice that this equation does not have y equals mx plus b. There is no y and x. It only has a y in its equation. So what we should know is from last module how to graph y equals 2. So remember, I remember it as if it doesn't have a y and an x, when I look at a y, it kind of looks like an upside down H. So that helps me remember it should make a horizontal line because all the y values are 2. That's what it means by graphing y equals 2. So it doesn't matter what the x's are, but when I graph those points there, when you connect them, it makes a horizontal line. So all you have to remember is if an equation just has a y, that you go to 2, here's the y, you go to 2, and then you make a horizontal line. So then it asks what the m. So if you think of a roller coaster, if a roller coaster was on this path here, they would be having 0 fun. So the slope, that helps me remember, the m is the slope, so the slope would be 0. And then where does it cross the y-axis? Crosses right here at 2. So this equation, when graphed, is horizontal. And remember, the word horizontal has an O right there, and the slope is 0. Okay, now if we look at example 4, when I look at this, it only has an X, so I remember it looks like a V at the top of an X. So I know it's going to make a vertical line. So I go to the x-axis, I go to 3, 1, 2, 3, and then I make a vertical line there. So M is the slope. Well, the slope, if this was a roller coaster, it would be undefined. So our M is undefined. And then where it crosses the y-axis, here's the y-axis, and it doesn't. So we would put none. There is none. And this was a vertical line.